like a solar panel, not in some huge factory, but literally one molecule at a time. Well, it sounds like science fiction, but scientists have just figured out a brand new way to do pretty much that. Let's dive into this huge breakthrough and see how they actually built a supermolecule that could totally reshape technology as we know it. I mean, really think about that for a second. Building the fastest computer chip you can imagine, or the most efficient solar cell, just by perfectly placing every single molecular piece where it needs to go. You know, for decades, this has been one of those holy grails of science, and with this discovery, we're a massive step closer to making it real. Okay, so at the very heart of this dream are these things called phthalocyanines. They're basically flat, carbon-rich molecules, and they're fantastic at conducting electricity. We actually already use molecules like these in the OLED screen on your phone, but scientists have always known they could do so much more. And the core idea has always been pretty simple, right? If just one of these molecules is good at moving electrons around, then a whole network of them, all fused together, should be absolutely incredible. In theory, a bigger structure would create this perfect, seamless superhighway for electricity to just flow right through. And that's really the secret to making faster, more efficient devices. So if the theory is that straightforward, you've got to ask, what's been the holdup? Why haven't we done this already? Well, it turns out there's been a really fundamental problem getting in the way, a chemical roadblock that has had researchers stumped for years. And here's the problem in a nutshell. As you start linking these molecules together to build that awesome electronic superhighway, the whole structure just stops dissolving. It clumps up, it becomes insoluble, and that makes it impossible to work with using standard chemistry. It's kind of like if your Lego bricks just suddenly refused to connect once your creation got too big. But a team at the CQIS Research Center has come up with an incredibly clever workaround. They've pioneered this new hybrid strategy that completely changes the rules of the game. It's a brilliant two-stage process that just sidesteps the whole problem. So here's how they pulled it off. First, they use normal chemistry, the kind in a liquid solution, to make all the initial building blocks. Then, to get around that whole dissolving issue, they take those individual pieces and lay them out on a special surface. And here's the magic trick. They trigger the final reaction on that surface to fuse them all together. They basically just change the whole environment to finish the job. And get this, one of the lead researchers pointed out a huge extra benefit. That special surface wasn't just a workbench, it was also a window. It let them use these super advanced microscopes to actually see the final structure with atomic level precision. So not only could they build their new molecule, they could prove it was perfect, all in one go. So what did all this clever chemistry actually make? Well, here's the payoff. They successfully fused 5 of those individual molecules into one single, complex, cross-shaped structure, a genuine supermolecule. And this is what's so revolutionary about it. It's not just 5 molecules sitting next to each other. No, they are so perfectly bonded that they act as one single, continuous electronic system. All the individual parts now behave as a unified whole. That is the exact goal scientists have been chasing for so long. Now, to really get why this is such a game changer, we have to talk about something called the energy gap. Just think of it like a little hurdle an electron has to jump over to get moving and create a current. The smaller that hurdle is, the less energy gets wasted, and the better the material is at conducting electricity. And that is exactly what this supermolecule does. A single individual molecule has a pretty high energy gap, a big hurdle for those electrons. But when they're all fused together into this new superstructure, that gap drops a lot. They've basically flattened the hurdle, creating a much smoother path for electricity to flow. Okay, so this is way more than just a cool experiment in a lab. This is a fundamental breakthrough in how we build things at the molecular level. It lays the groundwork for a whole new generation of technology. And the potential here is just astounding. We're talking about next-gen electronics that are smaller and faster than anything we have today. For energy, this could lead to solar cells that capture sunlight with almost perfect efficiency. This kind of molecular control is also absolutely crucial for developing things like quantum computers, and even for building sensors so precise they could detect a single molecule of a chemical. So what this research really proves is that building complex, functional machines from the molecule up isn't just a theory anymore. A huge critical piece of the foundation has just been laid. So the real question is no longer if these molecular machines are going to change our world, but when.